So that is physics. Yes. So today we are going to start the main concept, that is measurement. Right? So before going to that, I want to tell you something about it. Right? So it is not given in your state board book, but it has been given in your CBSE. So what are they? So in physics, many things will be governed by laws, principles and everything. So we are going to say that what is mean by principle, what is laws. So why they are giving different names? So somewhere they are saying principle, sometimes they are saying laws, hypothesis, axioms and models. Why they are giving different names to it? Right? So first we'll see about what is principle means. So what is a principle means? So principle is nothing but it is a rule or a mechanism by which a specific scientific phenomenon work. Right? So specified, in a specific manner only it will work. Can you able to understand that? Or simply I want to tell you in a language means I can say that. So principles are nothing but it is accepted only at the needed situations. So it is accepted only when we need it. So we call that as a principle. If we go for a law, so law is nothing but it is experimentally verified by taking into the all accounts of observations. So that means that it has been accepted everywhere. So I have explained you through the physics terms and things. If I want to tell you clearly about that means, we'll take a common example. Right. We all know about traffic rules. What it is? Yes, the traffic signals. So if a red light goes, what will do? We'll stop. If a green light is darkness, what will do? We'll get ready for it. If it is a green, then we'll start to move. So that is the traffic rule. When we obey that traffic rule? When we are traveling along the road. Am I right? So sitting in a classroom or in a home or in any places, we will not say that in that street red light is glowing now. So we will not stop our work. And green light is glowing now and we will start our work. We will not do that. Am I right? So we will obey that red, green and orange only when we are traveling on the road. We will not obey that when we are doing work in a home or in a school or in any places. Right? That is called as principles. So we obey that only at the needed situation. So that is called as principles. So if you want to tell a physics example, Archimedes principles or uncertainty principles, etc. So Archimedes principle is obeyed only when we immerse something in a liquid. Right? We will not take that for any other place. So only at the needed situation if we are using that means we call that as a principles. Is it clear? Right. Now we'll go for law. What is law? Example I can tell you. Yes, it is a theft. So if a theft is happening in inside our home or in a classroom or outside or any place, if a theft is happening, we call that as a theft. Am I right? So everywhere it has been accepted as theft. We will not say that it is taken inside our home. So it is not theft. We will not do like that, right? So everywhere, throughout the world, if something has been stolen means we call them as theft. Someone has stolen that. Is it right? We call that as a loss. So principle is a one. We'll say that it has been accepted as a needed situation, and a law is the one we'll use it everywhere. For example, to say about a law, I can say that it is a Newton's laws of gravitation. It is obeyed between two masses of an object to the entire universe and in all spaces. Am I right? So it is obeyed everywhere. We call that as a laws. Pascal's law, Kepler's law, you can go on saying. So that is the thing they are giving the name principle as principle. So apart from that, we are using a thing called hypothesis. So what is meant by hypothesis? So hypothesis is nothing but it is a supposition without assuming that is true. We will not say that, but we will assume something from our observation, right? So our assumptions of some happening is called as what? Hypothesis. So it cannot be proved. You cannot say that while doing so this will happen. We will not be able to prove that, but it can of what? Hypothesis. For example, it's an amphibian hypothesis. You will learn later in all the topics, right? So then, we'll go for axioms. What does it mean by axioms? It is a self-evident truth. It has a truth in it, right? Everything has been proved. It has been proved by it. Then we call that as an axioms. The last one is models. So what is a model? We already studied that in physics. Everything is governed through theoretical predictions. So for that theoretical predictions, we will do a model. We call that as a model. So I can say that the theory proposed to explain the observed phenomena, we call that as a model. Right? The model will clearly tell me what is happening, what is going to happen, right? So that will clearly explain that, we call that as a model. So these are the different terms we use that in physics. So we use principle, law, hypothesis, axioms and models. Right? So next we will go for fundamental forces of nature. Right? Now we are going to learn about the four fundamental forces of nature. Right? We can say this is a type of physics. So we can say that these four forces governs the entire world. Right? So before going to that, we learn about what do you mean by force. You have been learned from your lower classes. So we simply know that force is nothing but what? Push and pull of an object. Or I can say that a force is an external agency applied on a body to change its state of rest or motion. So we apply some force on a rest object, it will start to move. If any object is in a motion, if you apply a force in opposite direction, the object will come to rest. We call that as a force. Right? So it is a common definition. So what are forces? Simply we can say it is a push and pull of an object. Right? So there are four fundamental forces of nature. What are they? One is gravitational force, then electromagnetic force, then strong nuclear force and weak nuclear force. These are the four forces which governs the entire world. Am I right? Right. So we will study one by one. Now first, gravitational force. So what is a gravitational force? We know about our Newton's laws of gravitation. So we can say that the force of attraction between two objects of masses, we call that force as gravitational force. What it is? The force of attraction between two objects of masses, we call that as a gravitational force of nature. So that is Newton's law. You know about that Newton's laws of gravitation. What is that law of gravitation? You can say that every body attracts each other, right? It's directly proportional to the product of the masses and inversely proportional to square of a distance between them. We'll write that as an equation. So what equations we'll write? We'll write it as, what the formula we'll write? We can say that, we can say F is equal to, right? Or F is proportional to. What is F is proportional to what? The product of masses M1 and M2, and it is inversely proportional to square of the distance between the two masses. Right? If the proportional sign is removed, we can say that is equal to a constant called capital G, which is nothing but it is a gravitational constant. So that is a gravitational force. So which adds the entire universe that helps to us to lay on the surface of the universe. Right. The next force is electromagnetic force. So what is the electromagnetic force? Both electric and magnetic force join together to form an electromagnetic forces. Right? So we can say that it is a force of attraction between the two charged particles, or I can say it is between the two electrons, or it between the two charged wires. We call that force as an electromagnetic forces. It is a force of attraction between the two charged wires. Right? So that type of forces are called as what? Electromagnetic forces. And we can say that it is 10 power 36 times greater than that of a gravitational force. So it is 10 power 36 times greater than the gravitational force. And I can say that this both gravitational force and electromagnetic force belongs to a macroscopic world, that is, you can say that the range is a long range force, because the gravitational force can act between the two objects and between the earth and the sun, or it is nuclear force. So from the word itself it clearly tells you strong. So it is strong nuclear force. So what does the nuclear force means? You know about atom. An atom is made up of what? Nucleus. And nucleus is made up of what? Protons, neutrons, right? Nucleus is made up of proton and neutrons. We call them together, we call them as a nucleon. A proton and a neutron joined together called as a nucleon. Right? So we say that, so there are some forces acting in order to bind the proton-proton or proton-neutron or neutron-neutron together inside the nucleus. We call that force as a strong nuclear force. Now I am going to ask you one thing. So in gravitational force and electromagnetic force, we say one thing. What we say? We know about magnetism also. We say that the like charges or like poles repel each other. Right? The unlike charges attracts each other. Right? Am I right? So we can say in magnetism or in charge, we can say that a like charge repel each other and unlike charge attracts each other. You know that. That is governed everywhere, right? So if I say inside a nucleus, we'll take is the protons. If I take a helium, what does the helium stands for? We know that helium is what I write it here, He24, right? He24. I can say that the helium has 2 protons and 2 neutrons. And it has 2 electrons. So that 2 protons and 2 neutrons has been present inside a nucleus. So proton carries what charge? Positive charge. Right. So the 2 protons have same charges. As per the laws of physics, what has to happen? There should be a repulsive force between the 2 protons. But the 2 protons are staying inside the nucleus safe. Then what can we say? You can say the law of physics is wrong or the nucleus is wrong. No, both are right. Right? So what is happening there inside a nucleus? There is a repulsion force between a proton and proton. But against the repulsive force, one other strong force acts against the repulsion in order to bind the 2 protons inside the nucleus. We call that force as a strong nuclear force. Right? It is a very short range force. That means it is very small and it acts inside the nucleus. It is not able to see somewhere else. So already atom is very small and nucleus is very small and that force acts only inside the nucleus. Therefore, we call this strong nuclear force as a short range force. So that force is which is 100 times greater than the electromagnetic force. So it is what? Very strong force. We call as 100 times greater than the electromagnetic force. That strong force is called as strong nuclear force. Right? Good. Now we'll go for a last line, which is a weak nuclear force. So though the word it has weak, it is not as weak as gravitational force. Right? If they ask to arrange this in an order, that order strong nuclear force will come first and weak nuclear force next, then electromagnetic force, then gravitational force. Though gravitational force is applied throughout the world, but that is one of the weakest force among these 4 forces of natures. So when this weak nuclear force will arise? So it will appear only when there is an interaction between the elementary particles. So what is elementary particle? That is the basic particles like protons, neutrons, electrons. And then more number of elementary particles are there. You will study deep inside that in your nuclear physics. Right? So when this comes into interactions to one another in radioactivity, so like beta degree also, at that time a force will be organized. We call that force as a weak nuclear force. Right? Is that clear to you? So we have studied about the 4 important forces that governs the entire world, which is called as gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. These 2 forces will come under macroscopic world and it is a very long range force, and these 2 will come under a microscopic one, that is a very short range force. We can say that the range of thing can be 10 power minus 15 meter. So that within that only this range of force will act, that is 10 power minus 15 meter. Right? So that is a short range force. So here also the same thing, this 10 power minus 16 meter or so. So that type of forces which is very small and it is very strong, we call that as a strong nuclear force and weak nuclear force. So weak nuclear force will only arise when there is a radioactive emissions, when there is elemental particles involved in emissions. Is that clear? Right. Then next we will go for a law of conservation. Right? We will study that. Now we are going to study about the nature of physics class. So we are studying the basics about what are the principles, laws, hypotheses, axioms, and we studied about the four fundamental forces of nature. And another very important thing as a physics students, you have to learn that is a conservation of laws. So what does mean by that? So we can say that the physics phenomena is governed by different forces and several quantities may change with time, but something will remain same, or there is some special physical quantities will remain same with time. We call that type of quantities as a conserved. Conserved means it remains same before and after. We call that means conservation. So that is a conserved quantities of nature. We call that conserved quantities as law of conservation. So it is also one of the unifications that has been followed in physics. So wherever we go, we say that this is conserved. Any laws has been proved, we say that this is due to law of conservation of energy, law of conservation of charge, law of conservation of mass. So like that we will go on saying about that. So one of the unification of that is called as conservation of laws. So you have to know that as a physics students, you have to know these basics, right? So we are saying that some quantities will vary with time and some quantities will remain same. Right? With respect to time, we call that remain the same quantity as well. Conserved quantity, we call that conserved quantities as law of conservations. So mainly we can say these four kinds of conservations has been followed in physics. So one is law of conservation of energy, law of conservation of mass, and law of conservation of momentum. If momentum is that, we can say about two types of things. One is a linear momentum, another one is an angular momentum. So you can say that law of conservation of linear momentum and law of conservation of angular momentum. And the last one is law of conservation of charge. So I will explain this, right? The first one, the law of conservation of energy. So what I said conservation means it remains same. So same means what? So before and after it has to remain the same. So I can say that energy can neither be created and nor be destroyed, and we can say that throughout an experiment or throughout an observation, energy remains the same way. We can call that as a what? Conservation of energy. For example, if I want to tell you, it is a free fall of an object. You may be learned in your lower classes. So if a ball is falling from that, we can say that both potential and kinetic energy at different levels will be vary, but the total energy of that ball will remain the same. We call that sameness of energy as what? Conservation of energy. Right? So that is a free fall of object. Next is what? Law of conservation of mass. What a mass means? Here also we are going to say the same thing. What is? So mass can neither be created nor be destroyed. It will be changed from one form to another. So you may know your famous ancient equation, that is E equal to mc square. It says that the mass will be changed into rest energy and the rest energy can be converted into mass. So the mass will not be created or destroyed. So it may changes its form. We call that conditions as law of conservation of mass. Right? The third one, the law of conservation of momentum. So momentum means what? P equal to mass into velocity. So you can say two momentums. One is a linear one, another one is an angular one. Linear one means what? Which is a straight line. Angular means which is rotatory is called as what? Angular momentum. So we can say that where there is no external force acts on a system, then the momentum is conserved. Linear momentum is conserved. So example we can say about what? Anything else. Collision between two balls or so you will learn in your 10th standard. Law of conservation of linear momentum. Collision between two balls. So that is an example for what? Law of conservation of linear momentum. Then next is what? Law of conservation of angular momentum. I can say that when no external torque, right? Torque means what? study that later detail, right? If no external torques acts on the body, then I can say that the angular momentum remains the same. So that you will be detailedly studying in your 5th lesson, system of rotational motion, right? So that if we want to tell you an example, we can take an ice dancer. So if the ice dancer stretches their hand, so what will happen means the rotation of the body will be very slow because of the center of mass and the moment of inertia. If they hold their hands towards the body means then they will spin very fast, right? Due to this moment of inertia. We call that as a conservation of angular momentum, right? So law of conservation of momentum, that is linear and angular. Linear means no external force acts in a body, remain the same. Angular means when no external torques acts in a body, the body remains the same angular momentum. And the last, which is what? Law of conservation of charge. Right? In any equations we can see this law of conservation of charge. What do you mean by that? So the charges can neither be created nor be destroyed. Right? So it can be changed from one form to another form. If we want to take an example, we can take uranium. Uranium 92. That is 235 is bombarded with one neutron. It breaks down into barium and krypton. Right? So if we say barium means it has 56. Then krypton means 36. If I add, so here in uranium 92. So barium has 56 and krypton has 36. If I add 56 and 36, it gives rise to what? 92. So uranium 92 has been same as what? It has barium and krypton. So number of charges remains the same. Am I right? So it remains the same. That is called as conservation of charge. So in any equations we can see the stoichiometric of equation. So both reactant and the product part, the number of charges will remain the same. We call this as a conservation of charge. So these are the 4 basics or 4 things you have to learn about as a physics students. That is law of conservation of energy. Energy remains the same. And law of conservation of mass. Mass remains the same. And law of conservation of momentum. And momentum remains the same. And law of conservation of charge. Charge remains the same. Right? So these law is not given in your book. So we have to know as a physics students. Maybe you can refer your CBSE books. So that has been written. Right? So next we will go into our excitement one, that is learning of measurement. Now we are going to enter into that excitement one, that is measurement. So measurement is very important and needed thing in our life. If measurement is not there, we will not able to do anything else, right? So simply if I ask you one question, I can say I will ask you that, so who is taller in your home? Immediately you will answer your father, right? So if I ask who is taller among your father and mother, again you will say your father. Then if I ask how far she is taller or he is taller than other, then for that you need a measurement. How to compare with some standard unit to say that this much height comparison, right? You know that this much height he or she is. Am I right? If I go to a grocery shop and if I ask, give me sugar, he will ask immediately what the person will ask you. How much kilo of sugar you need? We will say 1 kg or 2 kg or 3 kg. If I go to a shop, right, cloth, I want to buy a cloth. If I will say, give me a cloth, means they will not give it. They will ask, immediately they will ask what? So how much meter you want? You need 1 meter or 2 meter. How much length you need? Right? So everything has been measured with a standard unit. Right? You will say it is standard one. So if it is a distance, that is length. If it is a weight or thing, quantity, it is a mass. Right? If I go to, if I am having a fever, if I go to a doctor, it will be like how much the temperature is, how far your temperature is. Immediately everything has been measured. If you go to your tailor and you ask to stitch your cloth, he will immediately ask your size and height. If it is not that, then he will give you a pillow cover to wear it. Am I right? So everything we are doing it, building buildings and everything, this has been done with the help of a measurement. That is the thing we are going to learn. So this lesson gives you a common idea about the entire thing, so that the other things depends upon. Alright? So we will say this. So the physical quantity. We call these quantities into two. Fundamental or a base quantity or a divided quantity. Or we can say it as a scalar and vector. Then we are going to learn about the prefix and suffix which is going to be used in these units, and we are going to learn about the dimensional analysis of this. So we call this thing as a measurements, right? So first, so we say this, the process of comparison is called as measurement. So we are comparing one with the standard value. We are comparing the height with the another person. We call that comparison is called as what? Measurement. Then as a physics, we will define the measurement. What a measurement is? A measurement is the process of comparing an unknown value, right? An unknown quantity with a known fixed quantity of the same kind. So same kind, right? So we're easily able to understand that it is a process of comparing, right? So what we are going to compare is some unknown quantity with the known fixed quantity of the same kind. We will not go for a something. If I am going and asking a shop, give me a 1 kg of sugar, he will not take to measure, right? He will not take a scale or a tape to measure 1 kg. He will take a what? A weight, right? A beam balance or anything, a digital balance to measure the mass. If we go to a cloth shop, he will not take a weight machine to measure the cloth. He will take what? Scale. So with the standard value, standard fixed quantity only, the thing has been measured. We call that as a measurement. Is it clear? So measurement is nothing but what? This is a process of comparing unknown one with a known fixed quantity of the same kind, not a different one, right? So we say that is a physical quantities. So physical quantities are basically has been divided into two things. One is a fundamental quantity, another one is a derived quantity. We can call this fundamental quantity as a base quantities too. So there are 7 numbers of fundamental quantities are there. So what is 7 quantities? So what is named by fundamental quantity? The physical quantity which is independent, which doesn't depend upon some other thing and it will not be expressed in some other term. We call that type of quantity as a fundamental quantity. Right? So what is a fundamental quantity? A physical quantity which doesn't depend upon any other quantity, which is independent. We call that type of quantity as a fundamental quantity. If we want to tell you some example, so length. So length is a one. We are not able to explain the length in some other quantity, right? So length is a fixed one. So with the help of length only the area, volume, and some other thing can be measured. So length cannot be measured in some other terms. So length is a fundamental quantity. With help of length, we are measuring area and volume, which that all come under derived quantities. Similarly, mass, temperature, electric current, right? So that are the 7 fundamental quantities. I named like this. One is length, second one is mass, third one is time, fourth one is electric current, and fifth one is temperature, and sixth one is luminous intensity, and seventh one is amount of substance. So these were the 7 fundamental basic quantities which we are using here, right? So what are they? Repeat it again. Length, mass, time, temperature, luminous intensity, right? Electric current, and next is amount of substance. So these are the 7 basic fundamental quantities, and these quantities cannot be explained in some other forms, right? Then what is derived quantities? We can say there are infinity numbers of derived quantities. Why it is? Because all the terms has to be depend upon the fundamental quantity. With the help of fundamental quantity, we are explaining some physical quantity means we call that physical quantities as a derived quantity. As already said, I said area, volume. These are not what it depends upon length. If I want to tell about the area of a square or a rectangle, what I say? It is length into breadth. So I am using 2 fundamental quantity, length into breadth. So that is called as derived quantity. If I say velocity, velocity means what? Displacement by time taken. So I am using displacement and time taken. I am using 2 fundamental quantities to derive velocity. We call that velocity as a derived quantity. So that the n number of derived quantities are there. So we label what is measurement means? A comparison of an unknown with a known fixed unit. So in physical quantities has been divided into what? A fundamental quantity and a derived quantity. How many fundamental quantities are there? There are 7 fundamental quantities are there. And how many derived quantities are there? There are infinite number, n number of derived quantities are there. What I mean by fundamental quantity? The quantities which cannot be expressed in any other form. The quantities which cannot be expressed in any other form is called as fundamental quantities, and the quantities which express in terms of fundamental quantities are called as derived quantities. Right? Now we'll go for a thing. So how the physical quantities can be measured. Right? So how a physical quantity can be measured? We have to choose a unit. If I go for a shop, they will ask what? How much meter of cloth you need. If I go to a grocery shop, now they ask how much kg of sugar they need. Right? If I go to a hospital, what is the temperature of a body? So they are giving something like meter, right? Kilogram, temperature, degree Celsius. They will say no, that is the measurement of physical quantities. So what it is? And all the 3 chosen standard of measurement. We are going to give a standard measurements of a quantity which is accepted internationally. We call that as a unit of a quantity. So what is that? For length, it is meter. For it is time, it is second. For a mass, it is kilogram. For electric current, it is ampere. Right? For luminous intensity, it is a candela, Cd. For amount of substance, it is mole. Right? So like this, the 7 fundamental quantities has the fundamental units, has the same units. We call that as a unit of quantity. Right? So everything will be represented with a standard one which has been accepted internationally all over the world. If I go to America, that meter is not a different language. So meter is common everywhere. Right? So kilogram is common everywhere. So internationally that symbol and this thing has been accepted, means we call that as a unit of quantity. Is it clear? Right. There are 2 types of unit. One is fundamental unit and a derived unit. It is very easy, right? The unit through which the fundamental quantities are explained is called as fundamental units. So how many fundamental quantities we are having? Yes, 7 quantities we are having. These 7 quantities has been represented with the help of a unit, means we call that as a fundamental unit. For length, it is meter. It will represent by m. For mass, it is kilogram, represented by kg. And for a time, it is second, represented by s. Then temperature, it is Kelvin, represented by capital K. Then electric current will be represented by ampere, capital A. Then luminous intensity will be represented by candela, Cd. Then last one, amount of substance will be represented by mole. Is it clear? So these things are called as what? Are fundamental units. Then the derived units. What is the derived units? So the unit by which the derived quantities has been expressed is called as what? Derived units. So if I say area, length into breadth, meter into meter square. So that is a derived unit. If I say velocity, displacement by time taken. So displacement in terms of meter, time in terms of second. So meter per second. Division means we'll use the word what? Per. So meter per second. So that is called as what? Derived units. So with the help of the fundamental units, we are deriving some other units, means we call that units as derived units. We represent by Q is equal to N. What does that Q stands for? Q is a known fixed quantity, right? That is a physical quantity. That is equal to N. N stands for a magnitude of a physical quantity or a number, right? So it tells you a number, and U is a unit in which it is expressed, right? So we can say that the N is inversely proportional to U. That means what? The numerical value is inversely proportional to the size of the unit. Then we can say that Nu remains constant. For example, we can say that if a ball is there, so the ball distance is 8 meter. Then I can say that the distance of the ball L is equal to 8 meter. So the L will be this. L is equal to 8 meter. So L represents a value, magnitude. U represents a unit, meter, right? The physical quantity is equal to, the physical quantity is here what? The distance, L. L is equal to 8 meter. Can you able to understand that? So this is the way we will represent the physical quantity, right? We are using these units, no? So these units have some specific phenomena. What are they? If I want to say that, all the physical units will have a suitable size, right? Then everything is easily accessible. That easily can be accepted everywhere, and it will not vary with time, right? It will not vary with time, and easily reproducible from one form to another form, and it is not depend on physical conditions like pressure, temperature, volume, etc. So these are some of the things which specify these physical quantities, right? So what we have learned now? We learned about the physical quantity. The one is a fundamental quantity, another one is a derived quantity. Then we learned that the quantity can be compared to the standard unit which has been accepted everywhere. It's called as a unit of a quantity, and in that also we are having what? A fundamental quantity and a derived quantity. Right? So we will represent the physical quantity in terms of what? Q is equal to NU. N stands for magnitude and U stands for the unit in which the physical quantity depends upon. Right? Now we will go for systems of unit. So you have from the past. So how far the system of unit has been changed. Right? We are going to learn about the different types of measuring systems. Right? So from the olden days till now, what are the system has been followed and how it has been changed now. The first system is FPS system. Usually everything will be represented in three things. One is length, mass and time. So if you want to tell everything, if I want to tell our height also, we say about this much height, right? So and we say how much weight. Everything on what date we have been born. So we will take use of these three physical quantities generally to represent everything, right? So we can say the height of our body and weight of our body on what date we have been born. So length, mass and time are the three basic physical quantities which will be represents everything. So in olden days, they initially followed an FPS system of units. What is the FPS system of unit? F stands for length, P stands for mass, S stands for time. So F, they measure the length in terms of foot, right? Then next, they measure the mass in terms of pound, and they measure the time in terms of second. So that measurement of system is called as what? FPS system, that has been followed by our what? Ancient peoples or old persons, right? Then next, this FPS system has been modified as Cgs system. What does it C stands for? C stands for centimeter, and G stands for what? Gram, and S stands for second. This FPS system has been slowly changed into a Cgs system of. Then later, it has been again modified into MKS system of units. What is that MKS system of unit? So M stands for meter and kilogram and second. Right? Length will be measured in terms of meter, and mass will be represented in terms of kilogram, and time will be represented in terms of second. So later in 1970s, all the scientists joined together and made a conference, and that is, we can say that it is a general conference of weights and measures, and they accepted the basic units, and they have been said as that unit as a SI system of units. What the SI stands for? It is System International. So that internationally they have get some idea from someone, and they have been accepted the units as an international one. We call that system as a SI system of unit. This SI system of unit is nothing but it is a modified form of our MKS system of unit. That is rationalized MKS system of units. Now also we are measuring the length in terms of what? Meter. Measuring the mass in terms of what? Kilogram. Measuring the time in terms terms of what? Second. But that measure has been accepted by all the scientists throughout the world. We call that units of system as SI, system of unit. SI stands for what? System International. So now we are going to learn that all the fundamental quantities, how they have taken from a common one. So if I say length means meter. I am not able to say that, okay, I become a prime minister or a president of this country and I say that my height will be the 1 meter. Means do you all accept that? Or I will say my finger length is 1 meter. If I say you will accept this, no. We know the standard length for meter. That standard length, where it comes from. Then if I go and say that my weight is going to be 1 kg, right? No one will accept it, right? So there is some standard mass to say that this much amount of quantity is 1 kg. Where it comes from, right? So everything has been given by the system of international. They have done some experiment or taken some materials. From that, they define the standard values and standard measurements we studied, right?